All right. Very good afternoon to everybody. I'm very happy to be here and introduce some of the works that myself and also my team and also my collaborators have done in the past years. Just introduce myself. I'm Frank. Okay, so today I'm going to talk about how for AI meets XR to design the intelligent and the immersive futures. Like I mentioned, I come from Singapore, and it's a very enjoyable flight. Okay, also I stopped over at Zurich. Okay, so I'm a professor at SIT, and have been working on the VR AR for more than 20 years, and also with 10 plus years in AI. So I also chairing the one of the flagship conference in VR AR and also computer graphics next year, SIGGRAPH Asia. So welcome everybody to the conference. Okay, and separately, I think that I met some of the young faces here who have the passion for entrepreneurship. Just to share with you that I also have been serving on the advisory panel for a few of the tech startups in Singapore, and also myself, together with my students, we spin off a company just last year. Okay, so. Let me try to, So let's look at, how the VR AR, okay. I know that everybody knows the VR AR, but just to share with you, that's actually VR AR started more than 50 years ago, almost 60 years. So this is a video captured in 1968. At that time, there is no term called VR or AR, okay. It's just called a 3D head-mounted display. The author of this prototype is Professor Ivan Sutherland. All right, so he is widely recognized as the father of computer graphics and also VR AR. The picture on the right side actually is taken from me when he came to Singapore, gave his keynote on 60 years of computing. All right, okay, so this morning I think that Meta announced some of their new models of VR glasses. I believe that everybody have tried different kind of VR headset. Like, HoloLens, okay, like Meta Quest, all right. So it's not something new. Even myself, I took a photo with all of those antique VR headsets last year in USA. So it's not a new topic, but the thing is that we have seen so many kind of different VR, AR headset or technologies. But if we look down, there are a few fundamental technologies that remain almost the same. Okay, I put them here. That is include the content, the display, the interaction, and also the tracking. Okay, if you look at any kind of those kind of VR or AR glasses, okay, they all have more or less those four fundamental technologies. And this is what I have been working since start of my research back to 2002, okay, working on. So, yes, this is what I started my career with VR AR back to 2002 and 2003. At that time, it's very simple. We don't have the VR glasses. We just use the stylus and also active shutter glass. It's not VR glasses, okay? And the data coming from the medical scans, and also biomedical scans. So we try to put the slices images together and use the volume rendering to reconstruct the 3D body. Yeah, so that's it, okay? So later, that when the computing power of graphic cards like GPU started to be available, we try to use it for something that's more complex. Like here, you can see, we try to model or simulate the protein structure, okay? And also, we try to simulate the surgery simulations, whether that when the doctors, they are trying to do the surgery planning, how those needles they'll navigate, all right, okay. So this is what we have done. That is, quite early. But later, we try to even look at something that is even more complex, 3D reconstruction, 3D scanning. So here you can see this is what my students captured the images of my university. We try to reconstruct the 3D models. And later, we find out all those buildings actually is static, nobody inside, okay? What about we try to do the scanning of the environment with the human bodies moving around, and that is a 4D capturing, okay? And the challenge, how to do this in real time. Real time means that you need to have at least 30 frames per second to generate the content. Okay, so it comes together with this prototype. Okay, we call it 3D telepresence. Basically, for the whole room like this. Okay, you have multiple cameras, and then you capture the images, the videos from different angles, and you put them together. Even the people like here. Okay, I'm moving around. This will be captured and reconstructed in 3D. Okay, what is the applications? Okay, the application is very obvious. It's for 3D telepresence. Okay, so this is what I works at the very beginning of the content. All right. So later, okay, I think there's something wrong with is okay. Just try to plug in again.
Sorry.
Yeah.
We're trying to fix the technical.
Oh, okay. Yeah. Okay. Yep. So. Yeah. Okay. So later we start to look at how the VR AR glasses. Okay, starting from 2015 around. Okay, so here are all the VR AR glasses that my team and also my collaborators we have been developed in the past few years. We start from something that is very simple, for example, but it's very funny. We try to decompose the VR AR glasses into something that can be 3D printed, and then the children or the student, they can just like playing with the Lego, put them together. You can have your own VR AR goggle. Okay, the cost is just less than $10 US. All right, okay. And then later we try to look at something that is more challenging, because if you look at all the VR and AR glasses, okay, they all have the fixed focus. So which means that the lens inside, there is a lens for all the VR AR glasses, okay. The lens is never changing the focus. Okay, so, but this is something that is not true in our daily life, because our eyes can automatically adjust the focus, depending where you are looking at, near or far or in the middle. Okay, so we are one of the team that we propose to use the tunable lens. So which means that the tunable lens is able to dynamically adjust the focusing power. And then when you are looking at something far away, the objects near to you will become blurred. And then vice versa, if you are looking at something near to you, the object at the far away will become blurred, okay? And that is very close to what our real life look like, okay? And that can mitigate these so-called avoidance accommodation conflicts, all right? So later that we are also thinking about, how to do something that is more simpler, okay? I can share with you the goal for all the VR AR researchers, companies, Meta, Google, whoever, okay? They are all bear this goal in their mind, the same goal, to make the VR or XR glasses to be just like your normal spectacles. Okay. However, there are a few dimensions that are very challenging. The first, it needs to be very compact, okay, very lightweight. Secondly, our eyes, like this spectacle, has about 90 to 100 degree field of view. Okay, our human eyes has each eye has about 110 degree. So which means that for the VR and AR glasses, you need to provide as close as possible or as big as possible field of view. Okay, otherwise you are just like looking through this window. All right. Okay, if you try the HoloLens, you know how it is. All right. So of course there are some other kind of constraints like the resolution, computing power, okay, the performance, okay. So we look at something, this is something that we have been working very hard for quite a number of years, even until now, okay. So we start to look at something that is used a hologram, okay. We call it a holographic near display. So the principle is very simple. We use a hologram, okay. We try to record the information on that hologram, and then we use a modulator that can dynamically change the information. So why we choose a hologram? Hologram is very thin. It's thinner than 1 mm. It's very light. Okay, it's just like a piece of paper or even lighter than that. Okay, it has a wide field of view, more than 80 degrees. Okay, so this is what we have achieved. You can see that this is the prototype we have developed. All right, so we have this technology developed and also published in the top conference journals. So this is the latest work. Actually, it is going to be presented in the next year in the ISMA conference in South Korea. Okay, so we use the so-called pin light display. Okay, for the time-wise, I will not go much into details, but you can just easily Google this one. Okay, so this is a prototype. So you can see that we have a number of those near display technologies available from the team, and also for interactions. Okay, so I just recap again: 4 pillar technologies: content, display, interactions. Interaction means that you can have interaction with the virtual objects. Okay, nowadays I believe that you use the hand, like the pinch, 2 hands, zoom in, zoom out, or you use some kind of like a controller, right? Okay, yes. So this is what I also started with my research. That was 2007. That's me. All right. Okay. So yes, I think that is. I think that someone just show. Oh, okay. Because I changed too much. All right. Okay. So actually, at that time, I used the so-called also it's not deep learning but machine learning, just 2 layers: features and then the conclusion, classification. Okay. At that time, I tried to use the machine learning, try to capture the features of the eyes, your hands, and also your head in order to achieve the interactions. All right. Okay. Of course, this is something that is nowadays, is quite popular for HoloLens, for all the, Meta Quest. They also support this finger-based kind of interaction technologies. All right. So I talk about the fundamentals, and then here are a few kind of, real applications that my team have been working with the industry. Okay. Actually, I have done quite a large number of collaborations with the industry, okay, providing these kind of simulations and educations for different purposes. So these are the 2 videos. One is for the mixed reality. The other one is for the virtual reality. So we worked with like a subway operator in Singapore, SMRT. Okay, we provide this VR and AR enhanced simulator to train the staff, just in case if the train has some issue, stop on the track. So how can the staff troubleshoot? What is the first step? What is the second step? How the people can just work together, all right? So we have developed those 2 systems for them, and they have deployed in their company, all right? And also, it's not just about one single user, all right? So most of the time, you just play with the VR, AR just by yourself. But what about, few people, 10 people, 20 people? Yes, this is what we have developed. We have a solution that allow multiple users. Each one, you can wear the glasses, okay, but you are interacting simultaneously with the same content. Okay, basically what I have done is what you can see. Okay, and also I can see what you have done, all right? So we apply this for the medical training and also for the 3D data validation. All right, okay, so that is what's a very brief introduction, what I have studied from my PhD study, okay, more than 20 years ago, until about the 20, I think the 15 or 16 around, okay? So for the fundamental technologies for VR, AR. Then AR started, okay? I clearly remember that, at the very beginning, when I started to look at how AI can work, the research is still focused on, CNN, convolutional neural network, all right? Very, very simple and basic, AI models. But at that time, I tried to figure out, whether that we can leverage on the power of AI and try to push the development of XR. Okay, so here is a summary about some of the research work that my team and also my collaborators have done in the past. So on the left side, you can see these are the XR technologies: display, content, interactions, and also all together. And at the bottom, this shows each of the so-called the foundation models for AI, like normal GNN networks, like generative AI, large language model, and also embodied AI. So this is what we have been looking at, how the synergy could happen. Okay, so I'm going to introduce one by one. Let's look at display. A lot of people are very familiar with the large language model like ChatGPT. A lot of people also use AI to generate the 2D videos, okay, or 2D images, okay. But if you look carefully, for all the AI models, okay, they are almost focused on the the digital side or the virtual side, not so much on the physical side. You agree with me or not? Okay, of course, robot is another story. I will cover it later, all right, okay? But if you look at those general models, large language models, okay, and also the picture editing, video generation models, okay, they're all working with digital content. But for display, this is something true. This is something physical, right? Is there any chance the AI can do this, can help with this? Yes, okay? So just for example, for this holographic near display, I just now mentioned it has a number of advantages. Wide field of view, lightweight, 3D direct perception. However, one of the major challenge is the time to compute the hologram, the content generation. And something that is even more challenging, the content generation is dependent on the hardware. Okay, the hologram, you record it, the modulator you choose, and also the laser source. How to generate quickly the content that you want to show on your holographic AR glasses. So we develop a neural network. We just create, the target image and the target hologram picture. We generate a number of those images and then try to do a training. And then at the end, the trained AI model is able to quickly generate high-quality hologram image for these holographic near displays. Okay, so this is something that I can say that in the whole world that we are one of the maybe just fewer than 20 teams who is able to do this because it requires not only about the AI model but also the hardware. Okay, to set up the laser-based holographic near display platform, it takes at least a few years to do that. Okay, so yeah, and then simulation. I think I talked to some of the, I think I'm very happy to be here because I met some new friends here, and also one of the new connections mentioned that they are working on the simulation, all right? So yeah, so actually my team is also working in collaboration with NVIDIA, okay? So actually, we are using the AI for AI, okay? The reason behind that, in order to have the models, especially the large models to be trained, you need to have a big data center. You need to have a GPU center. However, if you go into the real data center, you will find out you don't like to stay there for 20 minutes. Why? It's super hot. All right? A lot of energy are consumed in order to maintain the temperature. Because if it's overheated, your GPU server will just crash. Okay? In order to maintain the temperature, in order to control the temperature, you need to put a lot of air conditioner inside. That will keep the airflow and also cool the servers. But here is the question. How can I know how many air conditioners are needed? What is the best position that I should install my air conditioners? Is there any way that we can put this into a quantitative way and also in a visualized way? Yes, you can use the traditional kind of CFD software, okay? Computer fluid dynamics, okay? But this software, first of all, is very expensive. It's the professional license costs quite a big price. Secondly, to generate simulation, it takes a long time. So then, together with NVIDIA, actually NVIDIA came to me to say, hey, Prof, why not that we try to utilize AI to solve the challenge for AI? And that is what we work with, all right? Okay, so I think that, yeah. So you can see this is a traditional simulation method, okay? Takes quite some time. And then we just use our method. We can this is a physics-informed GNN, graph neural network. We're able to quickly generate how each part of the data center, the temperature will behave. All right, okay. So this is about, and then it's about the 3D generative AI. We can give a text prompt to ChatGPT to say, okay, I want to have a picture with the dogs playing with the cat. All right, that is okay. But that is 2D. Imagine that we live in a world that is not just 2D. Actually, we live in a world that is 3D. Okay, I have a distance with you. Okay, in my eyes, everybody is, I think that the chair is in 3D. Okay, whether that the AI is able to generate 3D content for VR, AR, and also for CAD, for some other applications? The answer is yes. So this is what we have done. So basically, we have done some work on the 3D generative AI. Give the input either a single image or multiple view image or just a text. We are able to generate the 3D data, like 3D models, novel views, okay, and even multiple instances. Okay, multiple instances mean that it's not just one instance. Okay, you can just, okay, give me 5 chairs. It gives you 5 chairs, all right? Application-wise, of course, VR, AR, and also some other kind of applications. So this is one application. So one thing that I also want to share is that actually, normally people think that VR, AR is just about wearing this goggle. Actually, there is one special type of the display for VR, AR, which is glasses-free 3D display. So which means that you do not need to wear any glass. Just look at the screen, like here. You are able to see the content coming out in 3D. Okay, technologically speaking, this is called auto-stereoscopic 3D display, glasses-free 3D display. However, this looks very cool. The thing is that you need to have the images from different angles. In order to generate these so-called multi-view images, you need to have a specific camera rigs. Okay, so what if I just want to use my mobile phone, just take a photo. I want to put up in the display and it come out. Is it possible? The answer is yes. Okay, so our team, back to 3 years ago, we developed the method, okay? Giving a random 2D image, we can analyze the image and decompose this image into several layers, okay? And because if we just simply separate the image into several layers, what you can imagine will happen? There will be holes generated, okay? Because it's occluded. So how to make sure that there is no holes for each of the layers? So we use the AI to generate the so-called imprinting network, okay? So that will generate to make the image with some kind of host to be complete, all right? And then with the different layers of images, you can just virtually generate the image from different angles, any random angle, okay? Just to share with you that actually my team just 1 day ago, we successfully finished not just for the 2D image, but also for the 2D videos. Give me a video, okay? Just use your phone. We are able to reconstruct the glasses-free 3D adaptable content. You can see yourself doing the dancing or walking come out from the window, okay? So yeah, so this is what my team had just finished, all right? Then there is also another challenge my team have been working on. So I worked with Oxford University and also with Nanyang Technological University of Singapore. So we came out with the idea. If you look at all the generative AI tools, you give an image, like a cat or a dog or elephant. Normally, you give them the complete image, just a cat or just a dog, okay? But actually, in our daily life, you take a photo, a lot of things are putting together. They are blocking each other. They are occluding each other, okay? Is it possible that with this partially visible image, are we able to generate the complete 3D models? Okay? The answer is yes. So this is our latest research. It's going to be published in next month, the ICCV 2025 in Hawaii, okay? But the paper is available on the website, okay? We call it A-model 3R, A-model 3D reconstruction from occluded to the images. You just give an image, no matter how many objects inside. You just select the object, whether it is complete or occluded. Just select your target object. Then you are able to reconstruct the 3D models very, very fast, okay? At very high fidelity. Yeah, all right? Okay, so, and then in the past, I think 3 to 5 years, there are 2 major technologies, the so-called radiance-based technologies for 3D reconstruction. Okay, so that is, one is NERF, the other one is Gaussian splatting, okay? So my team, together with a university from Finland, and we have been working, and also together with NVIDIA, we have been working, just give, for example, for the medical side, we just use a few scanning of the medical images. We are able to reconstruct the whole volume of the body. What is the benefit? You do not need to do 200 scanning. You maybe just do 10 or 20 scanning. You are able to get the whole picture of your body in 3D. okay? And this is a cake that my PhD students, she celebrated her birthday, she just take a few photos, and then just submit the photos into the neural network. You can see the 3D reconstruction model of the birthday cake. All right, okay. So I think that I'm almost coming to the end. So just to share with that, I have been, my team has been also been working on the generative AI for, for the virtual world. So that's like the movie Matrix, okay? You can just tell the agent, okay, give me a chair. The chair will come out in the real world. You just tell the agent to say, I want the red color to be red. It will change the red. Okay? Yeah. Yeah, okay? And this is my last slide, second last slide. So this is also something that is just freshly baked out to be published in this year's Secret of Asia in Hong Kong. The idea behind that, if I ask you, for example, can you just pass me that chair to me? Okay, can you just put it there? Okay, you understand what I'm talking about, right? But imagine that you are talking to a computer. Can you just put it there? The computer will start to ask you, what is it? What is where? Okay, whether that the computer, the AI, is able to reason out based on your words, natural language word. Give me that. What is that? Okay, so the agent is able to, based on the context, based on my pointing fingers, okay, my eyeglass, my gaze, and then try to reason out what is my intention. Okay, so just share with this video.
Rotate that.
Move it there. Move it there. Make that bigger. Give that to me. Delete that.
Yeah, okay. So we just did an extension, not just for the virtual world, but also for the real world, the robotics. Okay, so we apply the same methodology to the robot. Just tell the robot, hey, can you just go to and find the red balloon? The robot will do it. Okay, it can automatically navigate and try to identify and plan the path. Okay, so this is what we have done. All right. Okay, yeah. So just quick views. This is just the very beginning. All right. So I know that it's a concern. Some people are very much worried about the power or danger brought by the AI. But I think that, first of all, it's a long story, okay, but I think that this AI technology will continue to evolve, okay? And I believe that the human beings, we live in the 3D space, okay? The AI should also be able to handle, those kind of tasks in the 3D world. Okay, that is so-called spatial intelligence, all right? Okay, second, I want to share with everybody what I have shown is AI for XR. Does anybody think about how XR for AI? Okay, whether the XR can do something benefiting AI. This is a very interesting topic, and my team is working on this. Okay, I believe it will have some potential. All right, okay? We know it's not just about XR, AI for education, AR for finance, but whether that's vice versa. Okay, yeah, all right. So thank you so much. I think that I will have 3 minutes or 2 minutes left over. Yeah.
Ladies and gentlemen, let's give Doctor a big clap. Thank you so much for the presentation. Incredible research, incredible work.
Yeah.
I have a question about the real-life application of these technologies.
Yeah.
What do you think will be the most common use case in the real world?
Well, I think that we can see that there are a lot of applications, okay, come out, all right? Just for example, if we talk about the VR, AR, okay, a lot of people, there are some demos outside, okay, for the manufacturing, for the education, for training, training for industry, or even for military, or even for medical, all right? So those are the proven applications. For AI, okay, in terms of the synergy with XR, first of all, the embodied AI for the robot and also the virtual avatar will be something that will be more and more in the next, okay? So, let's talk about the embodied AI for robotics, just like here, right? So in the restaurant or in the lounge, you can have the robot just to serve you with coffee, with the tea breaks, okay? And then there could be okay, we have a robot outside, right? Just to say hello to everybody. Actually, it can do more than that. All right, okay? It can also just communicate with you to provide you some kind of emotional kind of value for you, just like elderly care, okay? Even can just, play around with the children, all right? Of course, some of the industry, like manufacturing, so you can just tell the robot to do some kind of general tasks, okay? I would rather say that, there is huge potential, all right, okay, yeah.
Doctor, thank you so much. Let's give Professor Frank a big clap once again.
Thank you so much. Thank you. Yeah, thank you.
Thank you so much.
Yeah, thank you.
Professor Frank Guan.